I'm Alex from WSU's Department of Chemistry, and today we're going to be going over the acid-base titration lab for Chemistry 101. The first post-lab question asks you to calculate the density of vinegar. Before we calculate the density of the vinegar, let's look at our formula for density. Density is equal to mass over volume. From this, we can see that we're going to need the mass of our vinegar sample and the volume of that same sample. Both of these numbers will come from the data that you collected during the density of vinegar portion of your lab. Let's look at our data to find the mass of our vinegar sample. To start with, we can subtract the mass of our empty bottle from the mass of the bottle with the vinegar. Using my data, I would say that I would take 39.878, which again is the mass of vinegar and my bottle, and subtract 13.627 grams, which is the mass of the empty bottle. Once I do this calculation, I would find that I have 26.251 grams of vinegar in my bottle. Now that we know the mass of our sample, we can plug in the volume of that same sample to find the density. The volume of our sample is equal to that of our volumetric pipette's volume. Here I used a 15 milliliter pipette. Yours might be different at home. To finish this calculation, I would then plug in this volume to my equation. I would then do 26.251, which is the mass of my vinegar, divided by 15.00 milliliters, the volume of that same sample of vinegar, and find that the density for this sample is 1.750 grams per milliliter. You will perform this calculation 3 different times, and in question 2, you will take the average of these densities. Question 3 asks you to calculate the molarity of acetic acid in your vinegar solution. To do this, you'll use the data that you collected from the titration portion of your experiment. For this example, we'll assume that we titrated a 15 milliliter sample of vinegar, which again comes from the volume on our volumetric pipette, with a 1.53 molar solution of NaOH. To start this calculation, we need to know the volume of NaOH that was required to titrate our sample. We can find this by looking at our initial and final burette readings. The total volume added to our sample is equal to our final volume minus our initial volume. Looking at my data, my final volume was 14.66 milliliters. I would then subtract my initial volume, which was 0.57 milliliters. Once I do this calculation, I can see that I've added a total of 14.09 milliliters of NaOH to my sample in order to titrate completely. Now that we know the volume of sodium hydroxide solution needed to titrate our sample of vinegar, we can go on to find the moles of sodium hydroxide that were used. We can do this by looking at the molarity of our sodium hydroxide solution. Before we begin, let's remind ourselves what molarity is. If we're talking about our sodium hydroxide solution, the molarity is equal to the moles of sodium hydroxide over a volume in liters of our solution. From our data, we know that we used 14.09 milliliters of that sodium hydroxide solution. But before we begin our calculation, we've got to make sure to take that milliliter value and turn it into liters. So we can say that we used 0.01409 liters of our solution. Using our molarity, which we know to be 1.153 moles of sodium hydroxide for every 1 liter of solution, we can cancel our liters and find that we used a total of 0.01625 moles of sodium hydroxide. Let's look at the balanced chemical equation for this reaction. We can see that for this equation, we have 1 mole of base for every 1 mole of acid. They are in a 1-to-1 molar ratio. Therefore, we know that if we used 0.01625 moles of sodium hydroxide, we can use that 1-to-1 mole ratio. So for every 1 mole of sodium hydroxide, we have 1 mole of acetic acid. We know that in our sample that we titrated, we had a total of 0.01625 moles of acetic acid. Finally, we can calculate the concentration of acetic acid in our vinegar solution. We'll do this using the moles of acetic acid, which we previously calculated, and the volume of our pipette, which would be the volume of our vinegar sample. To do this, we would divide our moles of acetic acid, which is 0.01625, by the volume of our sample. Don't forget to take your sample to liters. So in this case, I would have a volume of 0.01500 liters. Once I finish this calculation, I would find that my acetic acid concentration is 1.083 molar. You'll perform this calculation 3 times using your good titration values, and then you'll average them together. Question 5 asks you to use the average density and the average concentration that you calculated in previous questions to determine the mass percent of acetic acid in your vinegar solution. But before we do this, let's look at the general formula for mass percent. Mass percent is equal to the mass of interest, or in our case, this will be the mass of acetic acid, divided by the total mass of your sample. So for us, this will be the mass of our vinegar sample. And then you would multiply by 100 to make it a percent. Now we need to find the mass of acetic acid in our vinegar sample. To do this, you'll take your average concentration of acetic acid that you found previously. For us, we're going to say that our average concentration was 1.06 molar. So I would have 1.086 moles of acetic acid for every 1 liter of solution. Next, you'll need to multiply by a volume. You could really use any volume you want, including 1 liter or even 1,000,000 liters if you really felt like it. But to keep things simple, we're going to use the volume of our volumetric pipette. For us, this was 15 mils. However, don't forget to change milliliters to liters. My volume for this example would be 0.01500 liters. I can see that my liters will cancel out, and I'm left knowing that I have 0.01629 moles of acetic acid on average in a 15 ml sample of vinegar. Now that we know the moles of acetic acid in a 15 ml sample of vinegar, we can find the grams of acetic acid in that same sample. We can do this by multiplying by acetic acid's molar mass. The molar mass of acetic acid is 60.05 grams for every 1 mole. My moles cancel out, and I can solve this to find that in 15 milliliters of vinegar, I have 0.9782 grams of acetic acid. Now that we've found the mass of acetic acid in a 15 milliliter sample of vinegar, and we found the mass of that same 15 milliliter sample of vinegar, we can finally solve for mass percent. We can do this by dividing the mass of our acetic acid, which in this case was 0.9782 grams, by the total mass of our sample, which in this case was 26.10 grams. Don't forget to multiply by 100 to make it a percentage. And we can solve this calculation to see that we had 3.75% acetic acid. The final question that I want to cover is the post-lab question. In the post-lab question, you're asked to find the percent difference between your calculated mass percent and the mass percent that's displayed on the bottle. This is a number that you would have taken down in lab. If you look at your post-lab assignment, you can see the formula for percent difference is the difference between the calculated and the bottle mass percent divided by the mass percent on the bottle times 100. You'll want to subtract the smaller number from the bigger number to do this. What I mean by this is if we look at our example, I would take 4.5% and subtract 3.75%. After I do this, I could see the difference between these two numbers would be 0.75%. Now that I know the difference between the calculated and the bottled mass percent, I can finally solve for percent difference. I do this by taking my 0.75% and dividing by the mass percent on the bottle, 4.5%, multiplying by 100, and solving. If I solve this, my percent difference would be 16.7%. Thank you so much for watching. That's all we have for today for this post-lab assignment. I hope this video was helpful. If you have any remaining questions, make sure to contact your TA. If you need to find their office hours, they can be found on your course webpage. Once again, I'm Alex, and thank you for watching.